Let's try this one. So it's okay. This is from May 2013 paper 1-3. It says here, let f of r equals to this little guy, right? So what I can do is that I can um, simplify this thing right here just to get my answer. F of r plus 1 minus f of r. How is it this sluggish? I don't know. I don't want to say much. Oh yeah, I understand why. I'll deal with that later on. So this equals to f of nothing much, just r plus 1 here and r minus r here. So r plus 1 factorial r minus 1 minus r factorial r plus 1 r minus 1. So here we have r plus 1 and r minus 1 r plus 1 r factorial r minus 1 minus r factorial r minus 1. This is not going to be there. Then we take r factorial common. So okay, if we take r factorial common, this is supposed to be r plus 1 minus 1. So this is supposed to be r there. So we have here r square plus r minus r plus 1. So we have here r factorial r square plus 1. Next up, um, because of this, what we can directly say is that because I have this thing, there are two methods of solving this. One of them is using the comparable difference method, and the other way is this direct method, which involves I get this thing being exactly equal to this one, so I can directly substitute this guy in. All right. It's just trying to mess me up with a bit of situation here. So what I can do is that I can first of all use method number 1, which involves just replacing this thing right here with f of r plus 1 with this little thing here with f of r plus 1 minus f of r. So we have here, this is n plus 1. So I just start off with my, I'm going to show a few examples here just so that I can see what's the trend and what's the issue. F of r plus 1 means we have a f of n plus 2 because it's n plus 1. So we have to start off with n plus 2 minus f of n plus 1 plus f of n plus 3 minus f of n plus 2 plus f of n plus 4 minus f of n plus 3. This two of these will be enough to show what's happening here. Then we have f of, I'm going to start off with 2n minus 1. So we have here, no, 2n minus 2. So we have here 2n minus 1 minus f of 2n minus 2 plus f of 2n minus f of 2n minus 1 plus f of 2n plus 1 minus f of 2n. So what's happening here is that this one only stays intact. This thing gets cancelled out with second terms minus, this thing cancels out with third terms minus, n plus 4 cancels with four terms minus, n plus 5 with fifth terms minus, and so on. This is the last term. This guy gets cancelled out with the second last terms plus. This guy gets cancelled out with the third last terms plus, and so on. So in the same way, if I can subtract this from this somewhere in between, so this means that everything else in between gets cancelled out, and therefore we only have f of 2n plus 1 minus f of n plus 1. So therefore we have 2n plus 1. So it means we have r factorial 2n plus 1 factorial r plus 1. So it's going to be 2n minus n factorial. And we have n plus 1. So n factorial plus 1 no, n plus 1 factorial and then n. So we have, yeah, I don't think I can simplify this further than this. So yeah, this is my final answer. Any equivalent form will be allowed as my answer. All right. So yeah, simple enough. You just need to figure this thing out the way I did. From here to here, here to here, here to here, here to here, on and so on and so forth. Here to here, here to here. So here to somewhere in between, which means everything else in between gets cancelled out. Only we have these two left. Which two? This one and this one. That's the way things work. All right. So there we go.